Hi guys, we're back with another tech video. We're going to talk about cooling fans. Before we do, let's talk a little bit about this Jeep. This Jeep was not built by Motec. It was built many years ago in California to be registered in California, and it used the last generation of the Motec module. So this is not CAN interfaced. Now you might hear some whine in this Jeep. This Jeep's a little interesting. It has hydraulic steering and full hydraulic brakes, so it's got Hydro Boost. So let's take off and we'll talk about cooling fans. Now going back a decade or two, most vehicles just ran a DC brushed motor. It's just an electric motor. You put voltage and current into it and the motor's going to spin. The more voltage you put into it, the faster it's going to spin. The more powerful the fan, the more current it's going to use. But it was pretty much a dumb motor because it was based on kV or kilovolts. The more voltage you put in, the faster or slower the motor would run. By comparison, modern electronically speed controlled fans actually have tachometers. They know their RPM and they can spin the fan up or down basically from 0 to 100%, but we never go to 100%. We're going to talk about that. Now a little twist on the DC brush cooling fan motors is manufacturers wanted a little bit more control. They didn't want to just put 12 volts into the fan motor and have it screaming all the time. Also, when you take a motor and you go from off to high and you don't stage it, that can be somewhat of an electrical shock or load to the electrical system. So if you take, say, a JK 2-speed fan motor, and we're going to talk about why JK fan motor is 2-speed, and you go from off to high and you don't stage it through that low section, you could experience a 40 to 50 amp inductive spike from that fan going from off to high speed. The earlier fan motors that were designed to go from off to 1 speed work just fine. Sometimes they put capacitors and other devices in to reduce that inductive kick. Do the same thing on air compressor clutches. So we had 3 relay systems, 4 relay systems that would supply lower voltage to the fan motor and let it run at a lower speed. It would also stage it from off to a low speed, then to a high speed. Some manufacturers like GM were really big on dual fans. So the Camaros and Cadillacs in the 90s and even the 2000s ran 2 fans. They'd have a low-speed fan and a high-speed fan, sometimes a condenser fan. I've actually seen Cadillacs with 3 fans, one in front of the AC condenser so that it would work independently with the air conditioning system. So different systems were designed to operate the fan not in a discrete state, on and off. And these are discrete fans. But by varying the voltage or the number of fans, they could effectively control the cooling fan output. Vehicles that have a single fan motor have some options for variable speed, as we discussed. One is a dual wound motor. What that means is there's 2 sets of windings in the motor for low and high. And that actually works really well. Jeep used it in some of their more premium vehicles like the Grand Cherokee, Cadillac used it, Ford used it, but the dual wound brushed motors were expensive. They were large, they were heavy, so they weren't used as often as the simple single wound fan motor. When the JK came along, Jeep did something that was somewhere in between. It was definitely economy, aka cheap, but still allowed the ability to have a 2-speed fan motor. Most of you know that your JKs have a low speed and a high speed if you have a 7 to 11 gas or petrol JK. The way Jeep achieved those 2 speeds was to take a single wound brushed motor. They changed the voltage. They did that with what's called a voltage divider. A lot of you guys will call it a fan resistor. It's that large looking ceramic thing in the upper passenger corner of your shroud. And essentially what that does is when it goes into low speed, the low speed relay is in the TIPM, the high speed relay is on top of the driver headlight. And you say, well, why would it be on the top of the driver headlight? The reason is they want cooling air to get to that relay because that relay can see 20, 30, 40, 50 amps. And if your low speed relay goes out or your voltage divider goes out, your fan's going to go from off to high. And as we talked about earlier, that inductive kick is going to really shock the system. So they want that relay to stay cool. Now I have seen those relays melt. I've seen the harnesses melt. So if you have a fan problem, that's one of the first things you should do is go look at that high speed relay. And if it's melted, take a look at the low speed circuitry in your JK. So essentially what happens is when you engage the low speed relay, it sends power to that voltage divider, and that large resistor then divides the voltage and sends some of it back. It drops the voltage down to about 8 volts. At 8 volts, the fan runs slow. Most of you guys can't even hear the fan on low speed in the cab. When high speed is commanded, because let's say it's a hot day, or you turn your air conditioning on, then the high speed relay is engaged, and that sends full 12 volts to the fan windings, and the fan speeds up. We see the low speed circuits burn out all the time. It's usually the voltage divider, especially if you have a cheap aftermarket one, and then it just goes from off to high, and that in and of itself can cause damage. Now when the system is working as intended, it works pretty good. The fan's pretty quiet, and it does put out pretty good airflow. It is a 17-inch fan blade. Now this is a DC brush motor again. It's not a pancake motor, it's not brushless, so it's long, it's tall, so it takes a lot of room up for the performance that it has. Now part of the problem with the JK cooling fan circuitry is it's a little bit complex. There's a coolant temp sensor in the 3.8 engine. That sends a standard coolant temp signal. That is a thermistor. A thermistor is basically a sensor that changes its resistance based on temperature. So it sends that signal back to the computer, which then knows what the coolant temp is, because the coolant temp has a lookup table that says if the resistance is this or the voltage is this, because remember, the resistance modifies the voltage. Unfortunately, in the JK, the powertrain control module, that is the engine and transmission controller, does not control the cooling fan. The TIPM does. TIPM stands for Totally Integrated Power Module. Some of you guys call it the gateway module. Some of you guys call it a grenade with a pin out. Whatever you want to call it, that controls the cooling fan. So in the earlier JK, the power for the cooling fan actually went through the TIPM. And as you know, that could be 20, 30, 40 amps. I think they run a 60 amp main fuse, PAL fuse, in the TIPM for the cooling fan. So that's a lot of current to be running through an electrical module. Whatever the process, we find the high-speed relay is vulnerable, and the TIPM can be damaged, and the trigger wire for the high-speed relay is a ground signal. So after weeks or months of running without a low-speed circuit, somehow that can feed back into the TIPM and burn out the driver in the TIPM, and then you're pretty much screwed. You got to replace the TIPM, and I've done that many times. I actually had to do it to my wife's 2008 JK. So the TIPM now receives the coolant temp signal from the powertrain control module. It also receives air conditioning pressure, and that's important because you want to keep the condenser pressure under control. You want to see your AC condenser pressure 180 to 200 psi. If it hits over 200 psi, the high-speed fan comes on. If it goes over 300 psi, on a 110-degree day, that would be considered normal, but if you're running constantly over 300 psi, check the system. It might be overcharged, you might have an obstruction. So this little 17-inch blade DC brushed motor that has a voltage divider, it's not even a true dual-wound motor, has to deal with cooling this big SUV. In a stock Jeep, it's not so bad. Although I've seen stock Jeeps overheat going up to the mountain, but now you start putting 40s on it, you put a V8 in it, and the stock cooling system just isn't up to it. Remember, the vehicles that came with these Hemis and LSs have massive radiators. Some of these are 30 inches wide and they have dual fans. They have excellent cooling systems, but we're pretty much stuck with a core that's just over 20 inches wide. So the biggest fan you're really going to get in there is about 19 inches, and we're going to talk about that. But before we do, I want to mention the transmission cooler. In the earlier JKs, the transmission cooler was a failure. In fact, it was a failure to the point that it was a danger and caused Jeeps to burn, because the transmission would overheat, the automatics, they would spit fluid out the dipstick tube onto the exhaust manifold, and then poof, you had a campfire. And a lot of JKs burned because of that, and there was a lot of restrictions around the world importing JKs because of that issue. So issue one was Chrysler put the transmission cooler for the 3.8 JK at the bottom of the AC condenser. Now this isn't the best place to put it for a couple of reasons. One, it's at the bottom of the AC condenser, so it doesn't get a whole lot of airflow through the grill. Second, guys mod their Jeeps. They put 40s on. The 42 RFE is not a very efficient transmission, so friction equals heat, and that transmission built a lot of heat up. Now you put 37s or 40s on it, you put grill inserts in it, you put a light in front of the grill. The cooling fan did pull a little bit of air through that condenser, but it was pretty pathetic. What we recommend you do in our swaps is run a manual transmission condenser. There is no cooler at the bottom of it for the transmission. Then run a proper transmission cooler, and there's options, and we'll talk about it. Well, let's talk about it now so we can get it out of the way. You can run a B&M supercooler, you can run a Pentastar cooler. When the Pentastar came out, Jeep knew there was an issue with the transmission cooling in the earlier JKs, so they came out with a pretty nice cooler that went right in front of the condenser. Now they ran that in serial with the original transmission cooler at the bottom of the AC condenser. That's optional if you want to run it or not. I don't think it does a whole lot of good. I'd rather just see you run a larger cooler. So the Pentastar cooler works well, the B&M supercooler works well, and there's a lot of others out there, Hayden's, that also work well. My one piece of advice would be stay away from the soft finned coolers, the ones that dent easily, because if you're going to be off-roading and rocks and things are flung at that cooler, they're more easily damaged than the hard fin coolers. Motec developed an off-board rail cooler for both the transmission and engine oil, and it helps tremendously. If you got a Jeep on 40s, it's heavy, you're at altitude, you're towing a trailer, and you have the biggest radiator and the biggest fan you can get, and it's still running hot, a lot of that could be because of the transmission. Because if the transmission's putting heat in front of the AC condenser, then the AC condenser's putting heat into the radiator, that all adds up. It's cumulative. By the time the radiator gets the cooling air, it's not cool anymore, it's hot. And then we have high pressure under the hood, so this cooling fan has to suck warm or hot air into a high pressure zone from a low pressure zone. So the whole thing is just kind of counterproductive. So what these off-board coolers do is the same thing as the military does and exotics, is they get the heat away from the radiator. So we have a rail cooler on the driver's side that's for engine oil, and we have another rail cooler on the passenger side for transmission. We do offer different sizes based on available room on your rail. These are finned aluminum coolers, so they can be bashed up pretty good and not have any damage, but they are recessed up in there, and if you have rock rails, we haven't seen any damage with these. Now if you have electric rails with steps that come out or welded on rails that are solid, then there may be some fitment issues. So by off-boarding this air, what we're doing is we're putting that hot air into the atmosphere, not into the radiator, not into the engine compartment. And what we notice is not only do the temps drop dramatically, but the coolant temp stays more stable, because as the AC condenser or transmission changes load and the heat gets put into the radiator, the coolant temp fluctuates. We're seeing 20 to 30 degree drop in transmission temperatures when you run this in series with a traditional transmission cooler, and we're seeing similar results on the engine oil. Now the engine oil, most scan tools use a calculated value, so if you look at the value on an Aeroforce gauge or Super Chips, that's a calculated value, it's not real. Only like a Corvette with an oil temp sensor has the actual value, so use it for comparative purposes, meaning if before the cooler it's 240 and after the cooler it's 190, then you have a 50 degree drop. Don't think that is an actual number, because it's not. But let's move into the variable speed fans, and this is where a lot of guys have issues because they just don't understand how they work. They understand that a variable speed fan is not discrete, on-off, it's proportional, and you can drive it from 0 to 100%. Now when I said earlier that you don't want to drive to 100%, the reason is most manufacturers build in a duty cycle. If you overdrive that fan and it runs too long, it can thermally shut down. Also, the higher end of the scale, like 90 to 100%, can be used for diagnostic purposes for the fan and the computers. So you're going to see most fans are going to go up to 75, maybe 80%. And that's kind of where you want it to be. And on that thread, you got to remember that the fan doesn't run just off of coolant temperature. It runs off of air intake temperature, transmission temperature, vehicle speed, engine oil temperature, condenser pressure. So what happens is if your engine's running cool, you're at 190 degrees, but your transmission temperature is at 240, and then your intake air temp is at 210, all that stuff adds up and it can overdrive that fan. Inside of most of these operating systems is rider control, and what that means is the cooling fan will max out. It'll hit a certain value and then it will ignore these other riders, because it knows that if you add 20% to an 80% already driven fan, that fan's going to shut down. So that's where the tuning starts to get a little bit tricky, because you want maximum cooling, but you have all these variables that come into play. Let's talk about the Pentastar fan first. It is the least understood, and most of you know Jeep had a lot of problems with it. 2012 and 13, there were constant updates for the Pentastar cooling fan. They would do crazy things. They wouldn't turn on until 240 degrees. Other times they'd come on high speed at 180 degrees. It just didn't make any sense. As mentioned, the cooling fan is controlled by the TIPM. So the TIPM has a lot to do with the Pentastar cooling fan operation. The TIPM still receives the coolant temp signal from the PCM, and that's a pretty solid circuit. We haven't seen any issues with that. So here's my take on the Pentastar fan. When it came out in 2012 in the JK, it definitely was a more powerful fan than the 3.8 fan. It was not a 12-volt DC brush fan. This was a real electronically speed-controlled pancake outrunner brushless motor. And what that means is the outer can of the motor turns rather than the inner. That allows you to have more torque because you have more leverage now. So they upped the fan blade size to 19 inches. Going to a bigger blade has many advantages. The blade can run slower, so it's quieter, and at those slower speeds it can pull more air. So the 19-inch blade is perfect for the JK, and that happens to be the same size as the Camaro SS fan. It can pull a lot of air at low RPM, so most of my customers don't even hear their Camaro SS fans. They might hear it on a hot day with the air conditioning on, crawling, but for the most part you don't hear it. What's wrong with the Pentastar fan then? In my opinion, Jeep did not go with what was pretty much industry standard at the time. Now, fans all around the world used different control, and most variable speed fans use what's called a pulse width, and pulse width is basically just a digital signal that varies. You have frequency and then duty cycle, or on-off time, and then by changing that on-off time, you can control the speed of the fan, but the hertz or the frequency stayed the same. So, for example, GM ran 100 to 128 hertz in most of their operating systems. The Corvettes ran 128 hertz. The Camaro ran 100 hertz. The Caravans and such, when they had their external fan controllers, were running about 100 hertz. For whatever reason, Jeep went with 10 hertz on the JK. And not only did they go with 10 hertz as the frequency, but they made an inverse pulse width. So the lower the pulse width, the faster the fan would go. This is what creates the issue trying to integrate it into other systems, is it works backwards. If you were to connect it to a GM operating system or even a JLJT system, it would drive the fan slower when the fan needs to go faster. And yes, Jeep did go to 100 hertz positive coefficient drive on the JT and the JL, exactly the same as the SF. So that does seem to be becoming the standard in the industry. Now, if you run the Pentastar fan with a Tipham that's intended for it, you're pretty much okay. But again, the Tipham had a lot of issues controlling the cooling fan properly. So essentially what the Hemi guys did is they programmed the Tipham to run the fan at high speed all the time. This would just send a straight pulse width with a straight duty cycle and run the fan on high all the time. Now, if you're a fan of that, that's great. If you want to talk inside the cab with the windows down, that's not so great. Now, these new fan motors, whether it's the JL, the JK, the Pentastar, are pretty good fans. The JL fan is not sealed. The Pentastar and the SS fan are, so water can't get in. They have excellent bearings, they're brushless. These fans are designed to run year after year, unlike the earlier throwaway JK fan. So the Jeep I'm driving is a typical example. It's a California Jeep, and he had some tuning done in California, and they overwrote the fan control that we installed. Because it has this inverse control, it's like intake temp, transmission temp, are embedded in the operating system and cannot be easily switched. The SS fan is my favorite fan. It has all the attributes of the Pentastar fan, 19-inch blade, low speed. In fact, I find it more powerful than the Pentastar fan. I think it's pushing close to 4,000 CFM. It's quieter than the Pentastar fan. It's 100 hertz, positive coefficient pulse width, and it integrates really, really well into the GM system because that's what it was designed for. So the SS fan really is top of the line. It's a durable fan, it's a powerful fan, it's a quiet fan. It can be controlled for oil temperature, intake temperature, transmission temperature, coolant temp, condenser pressure, and it's all done on an OE level right through the GM computer. None of this Tipham nonsense that Chrysler is still trying to sort out. You can only stuff so much heat into this engine compartment, and it's a small engine compartment, and you can only work that fan so hard. And a lot of guys will tell me, hey, I got a Camaro SS fan and it never runs hot, even though they got grill inserts, winches, and lights in front of the grill. Hook up Torque or an app and tell me what your cooling fan percentage is. And they call me back and they say, well, I'm running 75% at 80 miles an hour. And I said, okay, now remove your grill inserts and your winch and your lights and tell me what you're running at. And they call me back, hey, now I'm running at 20%. So you're not running hot because the Camaro fan is just so powerful. But by not allowing that free airflow into the radiator, you're making that fan work really hard. You're making the electronics work hard. You're using energy because there is no free energy. So the alternator has to work harder, put that 20, 30 amps out to drive that fan. So you want that cooling airflow coming into the grill. You don't want to run grill inserts. I know Mopar sells grill inserts, but if you read your owner's manual, it says don't run grill inserts. So the first line of defense against overheating is getting cooling air into that radiator. And remember, before that cooling air gets to the radiator, it's got to go through a transmission cooler, a condenser, and then the radiator. And both of those are heating up that cooling air. So think about that next time you put a giant 10-inch daylighter right in front of your grill. Or you put screen door mesh on your grill to keep bugs out. You're also keeping air out because a bubble of high pressure will build up in front of your grill, and then the airflow will hit that and be diverted up over the hood. So we're going to see you in the next video, and I'm really hoping in the next video we're going to have something special. Thanks.